Elon Musk's SpaceX aims to launch the first Starship mission to Mars within the next few years, with a potential window as early as 2026. This ambitious timeline is contingent on several factors, including successful orbital refueling demonstrations and favorable orbital mechanics, which only align Earth and Mars every 26 months for optimal travel. Starship is a fully reusable spacecraft designed for deep space missions, including those to Mars. It stands at 50 meters tall with a diameter of 9 meters and can carry up to 150 metric tons in a reusable configuration. The Super Heavy booster, the first stage, is 70 meters tall and equipped with 33 Raptor engines that provide the necessary thrust to leave Earth's gravity. Starship will be launched atop the Super Heavy booster. After the booster separates, it will return to Earth for reuse. Once in Earth's orbit, Starship will be refueled by tanker ships to ensure it has enough propellant for the journey to Mars. After refueling, Starship will travel towards Mars, a journey that takes approximately 6 months. Upon arrival, Starship will land and utilize local resources such as H2O and CO2 to produce methane and oxygen for the return trip. After refueling on Mars, Starship will launch back to Earth, completing the round-trip mission. SpaceX has been conducting numerous test flights of Starship prototypes. The first high-altitude test flights and subsequent development phases are crucial to achieving the necessary technological readiness for Mars missions. These tests include flights to stratospheric altitudes and eventual orbital missions. Orbital refueling demonstrations, scheduled for 2025, these tests will validate the technology required for on-orbit refueling, a critical capability for the Mars mission. SpaceX plans to use Starship for lunar missions under NASA's Artemis program, which will serve as preparatory steps for Mars missions. SpaceX's Mars mission represents a significant leap towards making humanity a multiplanetary species, relying on innovative technology and ambitious engineering feats to achieve this historic goal. SpaceX's fourth Starship launch success lies in several key achievements that mark significant progress towards the goal of reusable space travel and deep space missions, including those to Mars. Successful launch and return. Both the Super Heavy booster and the Starship upper stage completed their respective missions successfully. The Super Heavy booster returned to the surface safely, marking an important milestone in reusability and cost reduction for future missions. Propellant transfer demonstration. This flight included a crucial test of transferring liquid oxygen LOX from the ship's header tank to the main upper stage LOX tank. This capability is essential for in-orbit refueling, which is a critical component for extended missions, including those to Mars and the Moon. The launch demonstrated improvements in the Raptor engines and other components, showing SpaceX's ability to adapt and enhance their technologies rapidly. This iterative process of development is key to achieving the reliability needed for human spaceflight. Milestone for NASA collaboration. The successful propellant transfer also fulfilled a part of SpaceX's $53.2 million tipping point contract with NASA. This success strengthens SpaceX's role in NASA's Artemis program, which aims to return humans to the Moon and establish a sustainable presence there as a precursor to Mars missions. Implications for future missions. Mars and beyond. The ability to refuel in orbit opens the door to longer and more ambitious missions beyond Earth's orbit. This technology will enable Starship to carry more cargo and crew to destinations like Mars without the need to carry all the fuel from Earth. Commercial and scientific missions. The reusability and versatility of Starship paved the way for a new era of space exploration, making space more accessible for commercial ventures and scientific research. Continued development. SpaceX plans to continue testing with more frequent launches, aiming for 6 test flights in 2024. These will further refine the technologies and operations necessary for reliable and routine space travel. Elon Musk's plan to catch the Super Heavy booster after its launches is a significant and ambitious step forward in rocket reusability. This concept involves using the launch tower, equipped with large mechanical arms Musk has dubbed Mechazilla, or robot chopsticks, to catch the booster as it returns to Earth. The goal is to have the grid fins of the booster take the load as it is caught by these arms. The primary benefits of this approach include eliminating the need for landing legs, which reduces the rocket's mass and cost. Additionally, catching the booster directly on the launch mount allows for almost immediate repositioning, potentially enabling the booster to be ready for another flight within an hour. This rapid turnaround is a critical element in Musk's vision for making space travel more economical and efficient. supporting more frequent and affordable missions to Mars and beyond. This method also aims to improve precision and reliability in booster recovery, leveraging SpaceX's extensive experience with landing Falcon 9 and Falcon Heavy boosters, which typically touch down on either ground pads or drone ships. If successful, this innovative catch strategy could significantly enhance the overall efficiency of SpaceX's launch operations. SpaceX's Mars mission represents a significant leap towards making humanity a multiplanetary species, relying on innovative technology and ambitious engineering feats to achieve this historic goal.